Hello, my name is Tom Kramer. I'm going to be going over the Donkeycar framework a little bit. I'm going to make a minimal vehicle, and then we're going to make a new part for it. And hopefully in the process you'll get a feel for how the parts work in general. So first I'm going to do is make a file, an empty file. I'm using Visual Studio Code. I'm going to open that file. It's an empty file. So first thing we're going to do is we're going to make a vehicle part. Import vehicle. So this vehicle is a container for parts to run in. So you can see here we imported the name, here we instantiate it as a variable called v, which is the same that's used in manage, and here we're calling the start, which is kicks off the run loop. And I'll set a breakpoint here. If you're like me, you're using Anaconda or a virtual environment to run in, you can do Control-Shift-P, and you can do Python and select workspace interpreter, and from there you might have some different workspaces. For me, I have a donkey environment. If you follow the default steps, you should have that too. So if you select that, that selects that virtual environment for debugging, and then you can go, if you're looking at something like this, you can click on this debug, and then you'll be able to click in this margin to set a breakpoint, and then hit this green triangle, and now you'll be able to step through your code. So here we make a vehicle. We can see it has some memory. It has a list of parts, which is empty, has some list of threads, which is empty, and it has a Boolean flag on, which is set to true. So we're going to dive into that. This is the start function. It has an update rate, which we've left to default, and a max loop count, which we've left to default. So just kind of briefly stepping through this. If there are any parts that are threaded, then we start those threads. Does a brief sleep, and now this while on is the main run loop. And you can see it sets a timer there at the top of the loop. It updates all the parts. If it checks against max loop to see whether it should break or not. It sleeps, and it's sleeping so that it achieves an update rate of whatever hertz you set for this. So it will calculate how much time, roughly 1/10 of a second, that it would need to sleep in order for this total update loop to be 1/10 of a second. That does, however, assume that all your parts finished in a timely manner. If one of your parts is taking a long time to update, then this won't run at 10 hertz. But this is optimally, if everything behaves nicely, it'll run at the frame rate you ask for. So here we dive into the parts, and we can see that there are no parts. So it doesn't really do anything. So let's make a part. So I'm going to stop this, go back to demo, and I thought an interesting part to make might be an OpenCV Camera part. So what you could do is you can search OpenCV Camera, getting started, and you might have some kind of test code like this that kind of shows you how to get started. I'm going to copy that and then make a new file. We'll call it test cam. Let's do, I'm just going to edit it right here. Test cam. Oop, yep, I already had my test cam, didn't it? Well, you can see I've already pasted it here. It's just doing all the code from that I copy and pasted from that demo. And we can do Python test cam, and you can see that there is the camera working from my my Mac. It's showing there. So I hit Q. All right. So how do we turn this code here into a part that runs as part of our vehicle loop? So the first thing we want to do is let's make a new file for that part. Let's call it, let's do CV Cam. Actually, I have a couple versions of it, so I'm going to call this CV Cam 3 because I have some other versions I was working on. And then I'll open that CV Cam 3. And so the first thing we're going to do is we're going to import OpenCV, and I happen to know we're probably going to need time. So let's make a CV Cam class. And let's init it. And most, actually, we'll keep it basic right now. We'll do no arguments. And we'll just get started by, let's looking at this. The first thing it does is it opens up a capture device with some integer which defaults to 0. If we want, we can pass that in, which we will at some point. So that initiates the video capture, and then it has a while loop here, and it looks like it calls capture read, and it gets a frame, converts it to grayscale, shows it in a loop, and that's kind of what we were looking at. It kind of captures the frame, shows it in an image. Right now what we're going to do is this part, we're just going to capture a frame. And so for every part, it has a run loop. In this particular run loop, this part is not going to take any inputs, so there's no arguments other than the default itself. But it is going to capture an image and return the image. So let's make a frame, and let's default our frame to none, so it's always there. And here we're going to return our frame. Now I'm going to make a let's keep it as simple as possible. Now we'll call self frame equals, actually it's return, so it's going to return a bool and a frame when you call self cap read. Okay, just like that, we've made an OpenCV video capture part that will open up a capture, and then as we run it, it will read a frame buffer and then return the frame buffer. So how do we add this to our vehicle? Let's move this back in the center, and let's go back to demo. Now I've dropped that part in the same folder as this demo, so from CV Cam 3. You want to import CV Cam, right? Yeah, this is our class name. Import CV Cam. Okay, so now let's make the part. Let's instantiate it. We didn't give it any arguments to start with. We could give it like a resolution, or we could give it an integer to tell which camera. If you have multiple cameras that you're going to capture, we'll go ahead and add that. But to start, we're going to add the camera there. We're going to instantiate it, and then we're going to add it to the list of parts of the vehicle. So you can just add it like that, but we're going to see there's going to be a problem. Let's do demo pi. What do I do? From CV Cam, import CV, okay. Okay, you can see it started the vehicle, and then, okay, it's complaining that CV Cam doesn't have a shutdown, so let's add that. But you can see it's also saying that it's giving us some problem with keys and inputs and what's going on here. So the problem here is that our part that we made has a return value. But when we created the actual vehicle, we didn't specify that it had any outputs. So if your return function, so the run, by adding this camera to the vehicle part list, its run function will get called. As it gets called, the outputs will be named. They'll be named some arbitrary output. We can just name that whatever. You could call it really any string that you want. It doesn't have to be camera image. Nothing special about that. But now by specifying that, you can see the error goes away. It's running the parts, and you can't really see it doing anything yet. It's just capturing that frame buffer, and it's not really doing anything with it. If we want, we can now step into it. So I'm starting in the debugger now. So I made a camera part, added it to the list of parts. Now let's dive into the start loop. Now let's dive into update parts. Now we have a part to run. So it gets the parts. It will check to see whether that part has any inputs. Right now the camera doesn't. And it will see whether that part is specified as a threaded part or a non-threaded part. We'll talk about that in a second. If it is threaded, it will call this run threaded, but ours the default is not to be threaded, so it will call the run method. And you can see it'll pass to that any inputs that we've specified. We haven't specified any, this is empty. So let's dive into this. And you can see it dives into our CV Cam, into our run method. Here it's calling capture read. And then capture read is returning a frame. And that frame is going to be in the outputs. It's captured here. And this output, if outputs is not none, it puts your outputs into this memory. And it's named, it uses the named keys. So it looks at the length of your keys, and this is why they have to match. It enumerates your keys, and then it puts them in memory for other parts to use. And then it continues on the part loop. So what if we wanted to have something that actually used this image for some other thing? Well, let's look at our example used this CV2 image show to show that image frame and check for a key and then release it. So let's do something similar. Let's go to CVCam 3 and let's make a new part. This part is going to be how about image show, image display, image display. And this one is just going to have a run loop, but this one is going to take an image as an input. And this is going to do CV2 image show. Needs some kind of a label. We could perhaps set that on the init, but we're just going to take it and we're going to show the image. And CV2, in order to show that image, it has to do this wait key. If you don't call wait key, I found it doesn't show the image correctly, which is bizarre, but it doesn't. And then here we're going to do we're going to define a shutdown. And this shutdown will be called when we want to do this destroy all windows. Okay, so now when this part runs, it's going to take an image as input, it's going to show it, and this one does not return anything. This just only takes the image. And we forget, let's add a shutdown to this guy. And for this, hopefully it'll make sense. We want to do this capture release. So there, it's initialized the capture, it's initialized the frame to nothing. As it runs, it pulls this capture, and then when it shuts down, it releases. So here's another part, CV image display. Let's go back to demo. Now we're going to import that, name part 2. Now we're going to make a display part like this. And now we're going to add it to the vehicle loop. In this case, now this takes named inputs, right? And we wanted to go find the image that we've named here, the output. So the output of this camera will be fed to the input for this display part. All right. Let's run that. Okay, CV2 has no attribute wait key. Let's see what I got wrong there. Looks like it's wait key. Okay. I didn't capitalize the K there. Alright, now you can see that it has made a little display part. And we can use that display part not only to display an image coming from a CV cam, but really anything else. If you had a Raspberry Pi camera or anything else, it would be able to use that display, use that image and display it as well. So here we have a part that produces an image and a part that consumes it through the input. Now, in order to do a more complete example of parts, I'm going to talk a little bit about threaded parts. So right now, when it starts this camera and it calls run, it's going to sit on this run loop as it's reading this frame buffer. If that takes a significant amount of time, that could actually affect the overall run loop performance. So what we can do is we can define a run threaded, and this will get called if, when we add this part, we specify threaded, which defaults to false, as true. If threaded is true, then a couple things will happen. One thing is it won't call run anymore, it will call run threaded. In this case, run threaded, this is going to get called in the context of the main run part loop. So now what we're going to do, and it's kind of done for us by the framework, we're going to define an update function. What's going to happen is, by defining threaded to be true, when that part is added, it's going to spin up a new thread, and it's going to use this update function to run that thread. I'm going to make a bool to see whether the thread is running. This is going to be used when we're shutting it down later on. While self-running, so what are we going to do? I'm going to pull the camera. Oops. And let's break out this camera. This is this camera read into the pull function. So that's going to pull the camera. So now I can optionally run it in a non-threaded mode, or in an update I can run it, and what's going to happen is, outside of the main context, it's going to pull this part. It's going to update this frame variable as frequently as it can. Whenever the update loop comes around to run threaded, and now it's going to be, it's going to return that frame. Now when we're shutting down, we want to set this running to false, and then that will allow this loop to break free and the thread to exit. And if we want, we can put just a little sleep there to make sure that, to give it some time for that thread to shut down before we call release capture, to make sure we don't call release capture before we call capture read. Or you could also protect here, there's a is open on the capture, so you could say if it is open and then read, and that might be cleaner than sleeping and releasing. But this is just a basic. The other thing we might want to do is we might want to specify camera. I don't know, it's not really a channel. It's an index, so if you have 2 or more cameras, you can specify something non-zero. Maybe we'll default that to 0. And that way, if you've got stereo camera or some complex setup, you can pass in multiple camera and you'll have a CV cam per camera. So there you go. Now, if we go back to demo, now that this is threaded as true, let's try running it. And the part appears to be running fine. Now it's, if we were to step through it, you would find that it would no longer call this run. It's now only calling run threaded. And we can verify that if you want. You can set some breaks here and run. It's going to sleep for a second as it starts up. Oops, actually I want to run this part. There we go. So now it's hitting our breakpoints now. Now it's calling update and run threaded, and it's not calling run any longer. See, if you look at our thread, you can see it's in the main thread, and here we're in this update thread for this CV cam object when it's calling this update. And if I run, you can see that this run threaded is called in the context of the main thread. So I hope that makes sense, and I hope that gives you a feeling for what this vehicle is, how parts are added, how you can specify outputs and inputs, how these outputs and inputs are mapped to the arguments and the return values for the run function.